that's never better than the upper antennas, except midday at the top of the cycle. And that's how the wave angles change. This is not standard guying. These are star guys. It didn't start out that way on this tower. The star guy is something that's a triangle that attaches to each tower leg, and then there's a separate like T, and then you have two guys from each leg. And I have that now at the top and now at the middle. I believe between Hurricane Sandy and the last tornado that came through, that's the only reason that the tower is still standing. A close-up shot. Eventually, I would like to side mount the 82-footer. The problem is, because of the terrain and the ledge and the nightmare that I'll tell you about when we're in another room after 1 o'clock, frankly, the problem was that I didn't have as much area to work with as guys as I would have liked. So to side mount that extra 2 feet up and 2 feet this way would be just enough probably to get it into a guy wire. So I just decided to put it there and leave it there. It works well, but 90 feet would be better. This is looking up from the ground. If you look closely, you'll notice that there are antenna elements that are bent on all the antennas, either from a combination of storms or, as the 120, the 130-footer once did, it literally fell off the tower at one morning during ARRL. Yeah. A shot from the distance. It's a close-up of the star guys. And if you notice, I use a lot of insulators. The reason I did this was, and you'll get varying schools of thought on this, I did this because I didn't want to have any possible combination of guy wires re-radiating and acting like antennas, especially with all the other antennas in close proximity. I think that mostly accomplished it, but it upped the cost enormously of each guy wire, not to mention the time and effort and the weight involved. Very tricky. And what you don't see, which you'll see later, is on each one of these points, I use ice sleeves, which is a little thing that you twist on over the end of the preforms. I use 1/4-inch preforms. There are no turnbuckles involved here. And what it does is, with ice sliding down the tower, which is a severe problem in my location, you want to make sure that the ice doesn't get in and slowly pry apart the end of the preform. Because once that starts to happen, you have serious problems, and you won't see it at 100 feet in the air. So ice clips, that's what it is. So I bought a lot of ice clips, which again added an enormous additional amount of time and significant expense. But I wanted to be sure that once these things went up, nothing short of a major direct hit from a bomb or a real act of, insane act of God would take this down. Because you don't ever want to have to go through this again. I've had to rebuild and put things up again, and it is a nightmare. Especially in these woods. There is no place to get in a crane or a helicopter or anything else. And the trees are all too close. Something that you find out when it's too late.
How much property do you have?
I have 2.4 acres, and very little of it is actually flat. Most of it is like this. Those were the rocks that were excavated just out of that one tower base. That tower base is 4 feet by 6 feet. Why, you might ask, is it so big? Glad you asked. Because you start digging and you pull out one of these massive things, and then you dig, and then you have to go dig more dirt out of it because you have to straighten it out. And then you hit another one of those, and so on and so on and so on. You'll see pictures and you'll better understand what I'm going to deal with. This, just for this tower, when I had a small backhoe up there, it took me 2 hours to find the one place on this entire top of the hill where I could get that base so I could get in guy wires. I literally had to go around. In each place we had to dig, and then we had to enlarge the hole, and then I had to figure out where the guys can go. My guys are not equidistant, and they're not equidistant in terms of angle either. Very, very tricky. This is, there's the house, there's the ledge on one side, the hill and the rocks, and they, by the way, they move each year. Stuff moves up, which was a problem with the tower base initially. I had rocks that were migrating up. We actually had to go back and dig in deeper over the winter before I poured concrete. One of the bases with the cables and Can
Just a
we
couple of
take, is
lines.
it possible to take the projector where we're going?
Next week we got.
Yeah, we
issuing
could-
QRP.
we-
You think so, Carl?
We could.
Okay.
Okay. 'Cause
Um,
we're-
This is just one guy wire, again, with the egg insulator. You can't, I'm sorry you can't see the ice clip on here. It's something you may want to consider, because you get a lot of ice here in the, there it is. Very important. I get a tremendous amount of ice at my location. Last year, we had a record 9 ice storms, from small to severe. It's unbelievable. Just where I am, I get the cold air that comes down the Hudson Valley, and I'm below freezing when everybody else around me is above freezing. We get ice. If you go another 10, 15 miles north, they get snow. If you go down the hill, they get rain. And this is what you have to deal with. This is one of the plates with the very, very large eye to jaw, 12-inch anchors. And you have to go out, I don't know how many of you have towers, you have to go out and you have to check these. You have to reorient them, you have to tighten them. If you don't, you risk having too much play in your tower, which can be really bad with some of the storms that we get. So there's a lot of maintenance involved. I haven't done what should be required, but one of the key things is when you do an installation, spend all the time it takes to research it and to do it right. You never ever want to have to do it over, and you never want to have to worry about it. Very, very important, aside from the birds liking this, if you notice, you asked about grounding. Each leg is grounded separately, and it goes into ground rods in the ground. The problem is the ground rods are not nearly deep enough. I have ledge. You can't drive ground rods into ledge. So what I had to do is essentially create ground. I bought number 2 copper, stranded copper, and I sent it out about 100 feet in each direction from each tower leg. And then I would clamp guy rods to it, often no more than a foot deep in the ground, dug by a backhoe. It was as deep as we could get it. And I essentially had them at like 10-foot length. So I went through probably 100 ground rods between the 2 towers to attempt to ground. And one of the problems is that ground rods in the ground up on ledge, when we get drought, the earth separates from the ground rod and you have no ground. So the thing that terrifies me the most is when we get these vicious storms after prolonged heat waves, because in effect I have very little ground. So now I go out and I water in some areas. There's only so much you can do. And if you notice, because of the winds and ice I knew I would have at my location, which would be an issue, I use something different. The traditional way of putting in towers is to stick a base in the ground and build vertically. That helps you going up, but it actually is a serious problem when you're dealing with storms and wind. So at the time that I had from KM1H's location, he was one of the first to use what's called a pier pit. The idea being, this is about a foot long, you stick it in the concrete, and it goes through this hole, which is a plate. This plate is not bolted into the tower. It's free riding. And then the tower leg attaches to that, and then you ground it. This helps offset the tremendous and varying strains on the tower as the tower flexes and moves around or is being rotated by the wind and the storms. Fractions of an inch built up over thousands of pounds multiplied by the vector forces of the wind and the ice and everything else can destroy a tower base or put cracks in it that ultimately can result in a colossal failure. I didn't want that. So what I did was we decided to try this method, which was still fairly new back then. It's the only reason my tower is still standing. And to give you an idea how significant it is, even without all the weight and without all the storms, when we had gotten up to 40 feet and we tightened and torqued the guy wires, as we were in the process of doing that, all of a sudden we heard a tremendous bang! And what happened was we had reached a critical point on one guy wire where apparently it overcame the forces of inertia and gravity and friction, and the plate rotated maybe a half an inch. But it did it like with the force of a minor earthquake. And it did it in the blink of an eye. And that was just at the 40-foot level before we had anything on us at all. And that was a real eye-opener in terms of what kind of forces can be involved. And then in the years since, with my antennas, some of them being torn apart, and rotators and boom-to-mast plates being torn apart in some of the storms, we cannot even imagine the forces up even at 50 feet, much less at 80 or 100 or 120 with big antennas and rotators. So this is, if you're gonna ever put in a tower, this is what you wanna do, even a modest tower. It's a lifesaver. And actually, I like being safe, and I want anybody on my tower to be safe. And this is one of the best things you can do for safety. Do we need to leave now, or we have a few minutes?
No, they haven't come and run.
Nobody's thrown us out yet.
Okay, good. Another shot from a different direction, you can see the other legs
So Bob, that's the only attachment between the tower base and
Correct.
the
That's
the
just
base
sitting on
itself?
there?
Just sitting on
It's
the
just
thing?
sitting on there, yep, but you gotta make sure you get this
right.
flat, okay? Now, to add to the fun, you might ask, well, why is this so wide? Good question, I'm glad you asked that. And instead of a typical 3 to 4 foot, box, if you will, this is actually about 8 or 9 feet long and about 6 feet wide. Why did I do that?
How deep is it?
I'll get to that. If you look, you see all boulders. Well, they're not just boulders, this is the ledge. This is actually the hill right here. And it's the hill right underneath too. The deepest we could get here without hitting ledge and with pulling out some of these rocks was 18 inches. That's as deep as it gets. 18 inches. And over here it's
You're getting away with murder.
and over here it's 9 inches. Okay?
Wow.
So
Oh,
I knew this was gonna be a problem,
Ah.
as there are many challenges unique to my location. So I thought, I gave this a lot of thought. What could I do so that this wouldn't be a serious safety issue? Because literally, if this fell just right, the top of it would scrape the house, which of course you don't want to happen.
Yeah.
So what I decided is, first of all the tower bases, we use a lot of rebar.
Yeah.
Okay, I constructed a
I
rebar
was just
cage,
looking at
steel
the
rebar, which is a real headache, but it's well worth it. In addition, because this was gonna be so incredibly shallow, I decided that the best thing we could do was to give it the most solid base possible. And we do that by not just the rebar cage, I would throw in whatever pieces of steel I could find, whatever aluminum I could find, and I would spread this out, hoping to dissipate the weight and the force as much as possible. Because if you have steel rebar going from here to here, and here to here, and crisscrossing every which way, you are in fact spreading some of the force out. And that was the best I could do. I didn't know if it would work or not, I figured it probably would crack. But hey, I had nothing to lose. Well, it's now 17 years later. I have 3 heavy Aggies and a small one, and I'm about to put up a monster, and it survived direct hits from 2 small tornadoes and a savage hurricane, countless ice storms and blizzards. Nothing has changed whatsoever. It works. And I'm probably the only station using something like this with a big tower that's fully loaded. It really did work. I didn't know it would work, I couldn't expect it to work, but hey, it worked, so cool. So that's important because sometimes you need to do things that might not appear safe, and sometimes you shouldn't do it. But if you apply logic and you research what you're trying to do and you figure things out, you don't need to be a mechanical engineer, although it helps. But you can figure out how to deal with challenges at your location to get what you need done. This is a 40-meter wire beam. It looks more impressive than it is. It's 3 elements, basically 50 feet, and uneven patterns in the trees. It works very well to Europe in the beginning of the opening. And then after that, it's not very effective.
What's
That's
underneath
basically
that
it.
pin?
Concrete.
And plate,
It's just
legs, what?
No, nothing. It's just the standard base plate. It's just that square that you triangle that you see.
No, I mean the pin as it goes into the concrete.
Oh,
What's
that goes
beneath
right
that?
into the concrete. That's all. It's
Tied into the rebar, welded in, what?
No, just straight in. That's all.
Only
It
about a foot
doesn't
and a half?
support. It doesn't
Doesn't
support
support
weight.
it.
I realize it's not
The tower
supported.
system
It's
is
in
around it.
place.
Right. If the concrete isn't supporting the weight, the pin won't matter. I guarantee it. And if concrete is supporting the weight, the pin only matters to keep it so that it
Right.
potentially rotates.
Wow.
But of course, over time, the point is that while it may rotate microns, and we never see it, it really doesn't. All it does is by not being locked in, it simply spreads the forces
Right.
out better than if it didn't. be allowed to
The
rotate.
guide wires are essential at your installation.
Oh, absolutely. Well, they're essential anywhere.
So the guy wires keep the bottom of the tower from kicking out.
Oh, yeah, absolutely.
Okay.
You know, and everything I did was over guided too. I mean, everything
Good.
I've done is a level up from what's recommended
Yeah.
by Rome, except for my tower base.
Right. They don't know about you.
Yeah, most people
Oh,
don't.
they do? Okay.
There's an antenna here, I can't find it. If you were physically looking at it with your eyes, it would jump out at you.
I can
See.
see.
Okay, yeah, I can see a wire right there. Unfortunately, while the cameras pick up some things, we don't see this foursquare, which you can just barely notice. This is the 80-meter foursquare. It just doesn't show up. I'm sorry about that. But basically, I cut the trees out of here, extended the backyard, put it in the foursquare, which used to be on the hill here, and it was a complete nightmare in the winter, because I'd have to climb the ledge to get up there, which, and especially given my health in recent years, this has been enough of a challenge, especially when it's under 2 feet of snow. So now, if something breaks, I go outside, and, you know, here, one of the legs is right under where the chair is. It's fixable.
Have you seen any performance difference between summer and winter when the leaves are on the trees?
I'm not sure, and I certainly haven't been on enough to know, but you wouldn't really know anyway on the low bands because propagation is so different and noise level is so different. What I can tell you is the difference between having this between the ledge here and having it up on the hill here, I noticed that. There is a difference. Are you getting the sign?
Yeah, I'm getting
Okay.
the boot here.
Okay.
Can we
Yeah.
interrupt for just a second, turn the lights on, please? And I see some new faces that showed up since I see Wayne.